Hello and welcome to this case study presentation as a part of CHI 2024. This work is entitled UserJourney2Vector, Enterprise Application of Transformer Models on User Telemetry Data. It was conducted by Sara, Tandon, and myself at Microsoft this last year. User journeys, jobs to be done, and personas are often used in product design to understand user processes and experiences in an application to identify areas with need for development or further research. As data scientists, we utilize vast amounts of telemetry data to understand our users' behavior and intentions in an application. However, distilling this complex data can be difficult. We leverage state-of-the-art machine learning methods to create a model that can not only predict a user's next step in a process, but isolates their unique behaviors to characterize and cluster users and display this data in a visually digestible way. Imagine the following point of view. You're a researcher tasked with understanding and improving user satisfaction with a software tool for building websites. Recently, your main satisfaction metric has undergone substantial changes, and you need to help narrow down potential causes of satisfaction changes to help your product building stakeholders understand where to focus their attention in order to appropriately respond. To help product stakeholders understand changes in satisfaction, commonly they may have seemingly simple questions about users like, how do people use our product? And what changes have occurred in user behavior to explain observed changes in satisfaction? With potentially vast quantities of detailed telemetry that shows us what users are doing in the app, their entire user journey can be tracked, and we can organize it into a series of steps, like so. In this user journey, the user starts and then visits the home page, the products page, and goes on to have several other telemetry events before ending their user journey. When we don't know what to look for, we can explore the data with different kinds of visualizations for sequences. For example, this SIGCHI diagram aggregates user paths through the app with a set of rectangular nodes of different lengths indicating the number of users who reach a given step, and bands of varying width connecting them, indicating the transition probabilities from event to event. A sunburst chart displays similar information to the SIGCHI diagram, but where the SIGCHI diagram only shows the relationship between pairs of steps, the sunburst can show multi-step user journeys so that the probability of every possible user journey is displayed, not just the transition between pairs of steps. With a reasonable number of possible telemetry events, these kind of visuals help us to answer questions like those previously mentioned. However, the greater the number of possible telemetry events and the longer the user's journeys are, the more complicated the visuals become, and it is difficult to answer the previously mentioned questions, how do people use my product, and what has changed about user behavior to account for changing satisfaction. Striving for better ways of representing complex sequences of events, we borrow from modern natural language representation with neural networks. Word2Vec is an early language model that tackled language at the word level. It uses neural networks to convert individual words into a latent representation vector, Z. This vector represents coordinates in a space representing the semantic meaning of words. Plotting words as points in this space, we can observe what the model has learned about the meaning of words with a scatter plot. Points closer to each other are words closer in meaning, and those that are farther apart are more different in meaning. Take the four words king, queen, man, and woman, for example. The point in the plot for king is closer to the point for man than the one for woman. Queen is closer to woman than man. Importantly, the distance in direction from king to queen is similar to that of man to woman. This demonstrates how the model represents the meaning of male versus female within the space. Similarly, if we plot the words walking, walked, swimming, and swam, we observe similar patterns, where we travel a similar distance and direction to get from walking to walked as for swimming to swam, demonstrating the model's representation of verb tense in the space. Transformer neural networks have extended this principle from single word representation to the representation of sentences, paragraphs, and even entire documents. Treating entire user journeys as if they are sentences or paragraphs, UserJourney2Vector uses transformer neural networks to represent user journeys in a similar kind of semantic space, yielding representation vector Z. This vector can be used in different ways depending on our goal or downstream task. For example, predicting the next step in a user journey or predicting user satisfaction. We can visualize Z using points in a scatter plot to help us understand the distribution of user journeys and how they relate to one another. Then clusters of points in this plot correspond to categorically different user journeys from dots in other clusters, which we can relate to different types of user behavior or personas. In an interactive scatter plot where we can mouse over individual points, we can see the user journey they followed and begin to understand what exactly these clusters mean. This helps us to answer the question, how do people use my product, by showing clusters of categories of use. Tying the clusters in this representation space to our satisfaction metric, we can also see which clusters had the greatest influence on the change in overall satisfaction and begin to answer the question, what has changed in user behavior to account for changing satisfaction? We can answer it by noting which clusters contributed most to the change. We could also predict at what step in the user journey expected satisfaction changed the most, although for simplicity, we did not explore this in the present study. For our case study, we conducted semi-structured interviews with 6 experts in the digital product creation process, including product managers, UX designers, and data scientists. The interviews were conducted via Microsoft Teams and lasted between 40 minutes to an hour. The main objective of these interviews was to understand the limitations of existing event sequence methods and the potential usefulness of the UserJourney2Vector model on the design and development of digital products. We began by querying the experts on their use of personas and user journeys. We asked each participant about their familiarity and frequency of use, as well as the benefits and limitations of the way they currently use such tools within their product groups. Next, we presented some examples of visualizations for sequential data, as in the sequences of their users' telemetry events, including a SIGCHI diagram and an interactive sunburst chart. We asked the experts to describe their familiarity with these kinds of tools, as well as limitations they perceive in their use. Finally, we introduced the UserJourney2Vector model and queried their impressions of the concept. Subsequently, we presented the interactive scatter plot of clustered user journey vectors, as well as visualizations for downstream tasks, including a breakdown of satisfaction by cluster and prediction of future user journey steps. The experts provided their thoughts on the possible benefits and limitations of such a system for visualizing user journeys in contrast to the previously discussed visualizations. The industry experts we interviewed all indicated familiarity with personas, as well as frequent use of them or similar constructs such as user roles. They indicated using them to provide a shared understanding of who you're designing for and why. Querying participants about the limitations of such constructs, we found that there is a desire to use telemetry data to better understand and develop personas, as purely qualitative approaches had the known limitations of tending to oversimplify user behavior and mostly remaining static, unable to change in real time to reflect true user behavioral changes. The participants also indicated familiarity with at least one of the event sequence visualizations we asked them about. Data scientists in particular noted that to obtain reasonable-looking sequence visualizations, one usually needs to perform substantial filtering on the data, and that there's always a trade-off between showing the full data and providing a readable chart. In addition to the visualizations like the SIGCHI diagram, which shows us the transition probability between every pair of possible steps, we also discussed the sunburst chart, with the useful property of showing the probability of sequences of multiple steps. However, participants noted that with some paths that were extremely similar, even with one step being different, they were not necessarily grouped proximally in the sunburst. After introducing the UserJourney2Vector model, experts commented on the simplicity and usefulness of user clusters in their work and how event sequence data can have higher impact on design by capitalizing on user clusters. All experts shared the sentiment that user clusters coming from telemetry is a great opportunity for quant-qual research. It could give us new users that researchers are not thinking about that are actually being accounted for in the model. Experts also noticed that splitting key metrics by user journey cluster over time is useful to help us focalize where the issues are, and that prediction of user journeys would aid in understanding edge cases or surprising versus common behaviors. Interpretability as well as accuracy and confidence concerns were discussed as potential limitations of the approach. In closing, the potential impact of the UserJourney2Vector model on interpretation of user telemetry data was provocative. Experts felt the model output could challenge and bolster qualitative methods, and its various applications could integrate well in their daily work. Thank you.